different types of functions. There are numerous amounts of functions, and a lot of them are pretty basic. When we talk about these, there is the basic one, and we call that our parent function. All the other functions that go off of that have a resemblance to that first function, but it's shifted around your graph, and in geometry you'll learn that's a translation, so it could be, or a transformation, it could be translated left or right, it could be rotated, it could be reflected, all of those things. We're going to start with the basic functions, the parent functions. So the first, we have a constant function, and that constant function is just a horizontal line. Your equation is f of x is equal to c. F of x is function notation. And it's saying the function of x. As you notice, there are no x's in this equation. So c is a constant, which means it is just a number. You might see equations like f of x is equal to 4. That's the one represented here. That is a constant function. Linear functions make straight lines, as you might guess. We are very used to seeing a general form of a linear function being y equals mx plus b. We want to keep everything in function notation, so we're going to say f of x equals mx plus b. The parent function is just f of x is equal to x. So it makes that straight line that happens to go through your origin. Whenever we have graphs, guys, make sure there are arrows on both ends because we know these lines keep going and going and going forever. All right? Third function is absolute value. I remember this as absolute value makes a v. So absolute value function, parent function, is just f of x is equal to the absolute value of x. So absolute value bars with x in the middle. Remember, absolute value turns everything positive. So when you're taking numbers out of there, we look at all of our y values, they're all positive. The next one we have is a quadratic. And quadratic comes from an x squared. Linear comes from just an x. Quadratic comes from an x squared. We see our parent function, f of x equals x squared. The full standard form of quadratic is an ax squared plus bx plus c. So this right here is something you will also see when talking about a quadratic function. Oh no. All right, moving on. A square root function comes from the square root of a number. Comes from the square root of a number, and it's just a partial curve there. It almost looks like it's half of an equation, or half of a graph, and that's sort of what it is. So your parent function is just the square root of x. A cubic is when you're cubing a number. So the parent function, f of x, is equal to x cubed. And I call this my disco function. One hand is going up, and one hand is going down at the same time. We also have a few representations that are not functions, and they're not functions because they don't pass your vertical line test. If we try and look at that here, if I take my vertical line and run it across this parabola, well, it's crossing in more than one place multiple times. If I take this and drag it across the circle, it's crossing in more than one place multiple times. If I take it and drag it across this squiggle, it's crossing in more than one place multiple times. If I take it and drag it across this piecewise function, it's crossing in more than one place at a time. So all of those are not functions. An exponential function is something that gets exponentially bigger. And I remember this because my exponent is an x. My exponent is the variable. So x isn't down below like in your cubic, it's up in the exponent. Next, greatest integer function, also called a step function. And you can remember that one because it makes little steps along the way. Alright, and when we write the parent function for greatest integer, you have double brackets. F of x equals double bracket of x. And that just means that we're taking the integers, so we're skipping all those fractions in between.